From the dawn of humanity, when people gazed toward the distant horizon and wondered what lay hidden beneath the endless waves, the ocean has always been a great mystery, a world both familiar and eerily unsettling. We have conquered the skies and set foot on the moon. Yet more than 80% of the ocean remains shrouded in unexplored darkness. Today, we will dive into a place where light cannot reach to uncover the strangest secrets of the ocean, where the boundary between life and death becomes more blurred than ever before. Welcome to Wild Oceania, the secrets of the most isolated and dangerous continent in the world. Please give us a like and subscribe to the channel to motivate us to create more high-quality content. Don't forget to comment your thoughts below so we can discuss together. Let's begin. Welcome to the deep, the final frontier and home to the world's most alien inhabitants. The sea is a vast, enigmatic expanse, with depths yet to be fully charted and life forms we are only beginning to comprehend. Beneath the rolling waves lie secrets and revelations that are simultaneously breathtaking and terrifying. Mysteries that have fueled human imagination for centuries. From the sunless seafloor to the kaleidoscopic coral reefs, the marine world is a place of wonder and dread, where the unknown shadows the surface. It is a realm both beautiful and lethal, a world that continues to mesmerize and haunt us with its hidden truths. In the deepest, darkest corners of this planet lies a mysterious kingdom that has obsessed humanity for ages. This blue wilderness is home to unfathomable abysses, where the sun's warm embrace is but a distant memory, and where shadows dance menacingly with the unknown. Its murky depths conceal secrets far beyond our reach, teeming with beings that are as fascinating as they are monstrous. As the waves incessantly whisper chilling tales of the horrors lurking below, a sense of profound unease creeps in, as if the water itself were a sentient entity, breathing, waiting, and ready to swallow us whole. In its frigid grasp, the line between awe and terror vanishes, and the true nature of fear emerges from the gloom, making us tremble before the presence of the eternal, mysterious deep. This aquatic world is the largest habitat on Earth, covering over 70% of our planet's surface. It supports an incredible tapestry of life, from microscopic plankton to titanic whales. The sea encompasses a diverse array of environments, from shallow estuaries and vibrant reefs to plunging trenches and desolate abyssal plains. It is a fascinating, complex world of marine life and staggering ecosystems. From the deepest scars in the Earth's crust to sun-drenched coral gardens, the water teems with life. It also serves as a vital resource for humanity, providing food, minerals, oil, and gas. The sheer diversity of marine life is staggering, with thousands of documented species. The brine also contains the chemical building blocks and elements essential for all life on Earth. Let us look closer at some of these magnificent animals, beginning with the blue whale, the largest creature to ever exist. These are just a few remarkable facts about a being that continues to inspire global awe and admiration. The blue whale is the planet's largest mammal and one of its most mesmerizing residents. Its heart can weigh as much as a motorcycle, with certain individuals possessing a heart exceeding 500 kilograms. Despite its colossal proportions, the blue whale feeds primarily on tiny shrimp-like organisms known as krill. During peak feeding season, they can consume up to 4 tons of food in a single day. This giant is so massive that its song can resonate across vast oceanic provinces. Indeed, its call is among the loudest sounds produced by any living being. While capable of diving to depths of 1,000 meters, these whales typically spend only 10 to 20 minutes submerged during each descent. Tragically, blue whales were hunted to the brink of extinction by 20th century whalers, though dedicated conservation efforts have spurred a modest recovery in recent years. Beneath the deep blue surface, where sunlight dissolves into ghostly silver streaks, an almost silent world operates under ancient, unyielding laws. Frigid currents surge through canyons and over continental shelves, carrying the scent of salt, kelp, and life itself. In this vast emptiness, a titanic figure glides, nearly invisible to the naked eye. This is the great white shark, one of the most formidable cold-blooded predators to ever rule the waves. Reaching lengths of over 6 meters and weighing more than 2 tons, it stands as one of the largest predatory fish on the planet. Its anatomy is a masterpiece of pursuit. A torpedo-shaped frame, a powerful crescent tail, and sandpaper-like skin that minimizes friction as it slices through the water. Powered by a unique muscular structure, the great white can achieve incredible bursts of speed, reaching nearly 40 kilometers per hour in short strikes. It is the raw power of a predator honed by millions of years of evolution. Yet, its most fearsome weapon is not its size or speed, but its sensory array, one of the most sophisticated in the natural world. An extraordinarily keen sense of smell allows it to detect a single drop of blood diluted in millions of liters of water from a vast distance. Lateral lines along its flanks feel the minute vibrations of struggling prey. Most impressively, its snout is dotted with hundreds of electroreceptor organs called the ampullae of Lorenzini, which detect the faint bioelectrical pulses emitted by the muscles of living creatures. These sensors allow the shark to find prey hiding in total darkness or buried beneath the seafloor sand. When hunting, the great white displays the chilling patience of a master assassin. It typically strikes from below, where the dim light allows its silver grey back to blend perfectly with the shadows of the deep. A single, violent thrust of the tail, and it launches upward with terrifying velocity. At times, the momentum is so great that the entire gigantic body, along with its prey, is launched completely out of the water. Iconic footage from South Africa shows these sharks reaching from the depths in mere seconds. With massive force, both hunter and hunted soar above the surface before crashing back into an explosion of white foam. It is one of nature's most spectacular displays of power, speed, and lethal surprise. Within its gaping maw sit nearly 300 razor-sharp, triangular teeth arranged in multiple rows. The front teeth slice and tear, while the rear rows stand ready as constant replacements. Over its lifetime, a single shark may shed thousands of teeth. Its jaws are not fused to the skull like ours. Instead, they are suspended by a flexible system of muscles and ligaments. This allows the jaw to thrust forward during a bite, creating a devastating impact. Because of this efficiency, the great white is often branded as the ocean's most ferocious hunter. It doesn't hesitate, nor does it waste energy on fruitless chases. Every movement is calculated, rapid, and crushing. Yet, behind this image of a killer, the shark follows strict ecological mandates. In nutrient-rich waters, scientists have observed that great whites maintain a loose social hierarchy. Larger individuals hold dominance, yet direct physical conflict is exceedingly rare. Instead, they communicate through parallel swimming, tail slapping, or body posturing to size each other up. A simple rule prevails. The first to arrive usually claims the right to the hunt. The great white also possesses a rare biological trait for a fish: the ability to maintain a body temperature higher than the surrounding water. This thermal regulation allows its muscles to remain highly efficient even in cold currents. This allows the shark to undertake epic migrations, crossing thousands of kilometers of open sea to follow seasonal food sources. In the intricate web of marine life, its role is paramount. As apex predators, they regulate populations of large marine mammals like seals and sea lions. By culling the weak and the diseased, they ensure the health and stability of prey species. Their mere presence dictates the movement of other animals, indirectly sculpting the entire ecosystem. Yet, despite its dominance, this ancient hunter faces its greatest threat from humans. Overfishing, pollution, and the shark fin trade have decimated their numbers. Given their slow reproductive cycle, the recovery of the great white population may take many decades. Pop culture often paints the great white as a bloodthirsty monster stalking humanity. But reality is far different. Attacks on humans are remarkably rare, usually resulting from mistaken identity when a shark confuses a swimmer for a seal. Often, the shark delivers a single test bite and immediately disengages. The image of a relentless man-eater is largely a cinematic illusion. In truth, humans are not part of the shark's natural diet. Paradoxically, we are the species that poses the ultimate threat to their survival. By understanding this ancient guardian, we see that the great white is an indispensable pillar of the ocean's equilibrium. Another captivating resident of the deep is the clownfish. It is one of the most recognizable and beloved species on Earth, largely due to its starring role in the hit film Finding Nemo. However, these vibrant beings harbor many other fascinating traits. They are commonly found in the warm waters of the Pacific and Indian Oceans, primarily nestled within coral reefs. They're named for their bold colors, which resemble a clown's face paint. Most clownfish species live in a sophisticated symbiotic relationship with sea anemones. The anemone provides the fish with sanctuary and protection. In exchange, the clownfish keeps the anemone clean and healthy by consuming dead tentacles and debris. Clownfish are notable sequential hermaphrodites, meaning they are born male but can change sex to become female as they mature. This biological flexibility ensures there are always enough females to sustain the colony. In the wild, they can live up to 10 years, though in a controlled environment, they may reach 20 years or more. Much of their on-screen behavior is scientifically accurate, save for a few dramatic flourishes. In reality, a clownfish would rarely cross an entire ocean to find its offspring. While popular as pets, they require specific conditions and are not easy to maintain. They are also currently threatened by overfishing, habitat loss, and the warming of the seas. Clownfish are truly remarkable, possessing complex social structures and unique survival skills that allow them to thrive in the competitive environment of the reef. Though they are stars of fiction, these colorful fish deserve our respect for their resilience and their ability to adapt to environmental shifts. Perhaps no marine resident impresses humans as much as the dolphin. This marine mammal is widely regarded as one of the most intelligent beings on Earth, possessing skills that have ensured its survival for millions of years. There are over 40 distinct species of dolphins. They range dramatically in size, from modest 1-meter species to giants reaching 9 meters in length. The smallest is the Maui dolphin, found only in the waters of New Zealand. Dolphins possess brains that are larger and more complex than those of almost any other animal. They're capable of solving intricate problems, engaging in complex social communication, and even demonstrating self-awareness. They are profoundly social, living in pods that can number in the dozens. They utilize a sophisticated vocabulary of whistles and clicks to communicate. Known for their agility and speed, some can swim at velocities of up to 60 kilometers per hour. They are also famous for leaping from the water and performing gravity-defying maneuvers. Much like bats, dolphins use echolocation to navigate and pinpoint prey. By emitting high-frequency clicks and interpreting the returning echoes, they can determine the location, size, and shape of objects. They inhabit every ocean on the globe, from tropical shallows to polar depths. They are especially prevalent in regions with high fish concentrations. While generally peaceful, there have been instances of aggression when they are defending their young or feel cornered. Dolphins are extraordinary beings with a repertoire of behaviors that continue to fascinate scientists and the public alike. Yet, they face growing dangers from pollution and industrial fishing. Urgent conservation measures are required to ensure the survival of these cetaceans for generations to come. Another iconic marine animal is the sea lion. This marine pinniped is found across various global regions, from subpolar waters to temperate zones. They are celebrated for their playful nature, their high intelligence, and their distinctive rhythmic barking. Several species exist, including the California, Galapagos, and the massive Steller sea lion. They vary in size, measuring between 1 and 3 meters depending on the species. Sea lions are gregarious animals, congregating in large groups known as colonies. These rookeries can be immense, sometimes hosting over 1,000 individuals. Males are significantly larger than females and possess a distinctive mane of thick hair around their necks. They use these manes to signal maturity to mates and intimidate rival bulls. Sea lions are masterful swimmers and can remain submerged for up to 20 minutes. They are capable of diving to depths of 200 meters in search of food. As carnivores, their primary diet consists of fish and squid, which they seize with sharp teeth. While often trained for public performances, this practice has faced criticism from activists who argue it causes the animals unnecessary psychological stress. They are currently threatened by overfishing and the degradation of their habitats. Certain populations, such as the Steller sea lion, have seen dramatic declines in recent years. Despite these trials, sea lions remain beloved icons that capture the human imagination worldwide. Their playful spirit makes them unique, whether in the wild or in sanctuary. By working to protect these animals, we ensure they continue to flourish for future generations. Another mysterious yet equally fascinating marine creature is the ray. The giant manta ray is one of the sea's true titans, with a wingspan that can reach 9 meters and a weight exceeding 2 tons. They are found in oceans across the globe. They favor warmer waters and are frequently spotted gliding near coral reefs. Mantas are filter feeders, swimming with their enormous mouths agape to harvest plankton and small fish. They utilize specialized structures called gill rakers to strain food from the water. Despite their intimidating size, they are harmless to humans and often show curiosity toward divers. The giant manta is among the most intelligent of all fish, possessing a brain significantly larger than its relatives. It has a remarkable capacity for problem solving and displays intricate social behaviors. Unlike many other rays, the giant manta lacks a defensive stinger on its tail, posing no threat to humans. They are elegant swimmers, gliding through the water with effortless grace. They are also known to breach the surface, performing stunning acrobatic leaps. Unfortunately, these giants are threatened by overfishing and the impacts of climate change. With some populations declining sharply, conservation efforts are vital for their continued existence. The manta is a truly remarkable being that continues to captivate the world. The oceans are deeper than any mountain range on land is high. They even contain underwater waterfalls. These are caused by variations in water density and occur in places like the coast of Mauritius. The world's seas hold more gold than all the gold ever mined on land, an estimated 20 million tons, though it is spread so thin it is nearly impossible to extract. Certain denizens possess the gift of bioluminescence, meaning they generate their own light. This includes the lanternfish, which uses a glowing lure to attract prey in the midnight zone. The seas contain a staggering amount of salt. If dried, it would be enough to cover the Earth's entire land surface in a layer nearly 150 meters thick. The blue whale remains the largest animal to ever grace our planet. At over 30 meters long and 200 tons in weight, it dwarfs even the most massive dinosaurs. Failure to protect our oceans could lead to a catastrophic loss of our most precious resource. As we delve further into this vast habitat, we will uncover many more wonders. The sea plays a fundamental role in regulating the global climate by sequestering heat and carbon dioxide. This stabilizes the Earth's temperature, allowing life to flourish. Humanity relies on the water for sustenance and energy. Millions worldwide depend on seafood as their primary source of protein. The deep also supports the livelihoods of fishermen and coastal societies. Marine habitats are among the most diverse and vital ecosystems on our planet. They moderate global temperatures by transporting absorbed heat across the planet. Without this thermal conveyor belt, many regions would be uninhabitable. Conserving and restoring marine environments can mitigate climate change by keeping carbon safely locked within the seafloor. Marine preservation is also essential for human health. Many modern medicines are derived from the sea, including potential breakthroughs for cancer and heart disease. Thousands of meters below the surface, where the last vestige of sunlight vanishes, the ocean reveals a dark, freezing world that feels alien to terrestrial life. Pressure here is hundreds of times greater than at the surface, and temperatures hover near freezing. Every scrap of organic matter drifting from above becomes a priceless treasure. Yet, this abyss is far from empty. In the infinite darkness dwells a community of diverse life forms that have evolved along radical paths to survive this hostile environment. Many species take on forms beyond our wildest imaginings. Anglerfish lure prey with biological lanterns, while translucent jellyfish drift like ribbons of living light. Various shrimp and squid species pulse with bioluminescence to communicate, camouflage, or baffle predators lurking in the shadows. Bioluminescence is one of the most prevalent adaptations in the deep. It is estimated that over 70% of organisms in these lightless layers can glow. In this strange realm, energy is a rare luxury. Consequently, the struggle for limited resources is the primary force sculpting the entire abyssal ecosystem. Deep-sea organisms occupy many ecological niches. Some are specialized scavengers, waiting for manna to fall from the sunlit waters above. Others are patient ambush predators lurking in the dark. Many survive through symbiotic relationships with chemosynthetic bacteria on the seafloor. In the vast emptiness of the deep, life is usually sparse. But when a concentrated energy source appears, the ecosystem erupts into activity. A prime example is a whale fall, when a whale carcass sinks to the bottom. Within hours, sharks, hagfish, and crabs congregate for a feast that can last for years. Similarly, hydrothermal vents act as biological oases. Here, mineral-rich, superheated water erupts from the Earth's crust, fueling the growth of bacteria. These bacteria harness energy from compounds like hydrogen sulfide to produce nutrients. Around these vents, a community of truly bizarre life forms gathers. Giant tube worms live in protective casings and rely on symbiotic microbes. Yeti crabs farm bacteria on their own bodies as a mobile food source. Shrimp and giant clams also swarm these energy vents. All depend on the same limited resource, making competition inevitable. many species have evolved in different directions to minimize direct conflict, a biological strategy known as resource partitioning. The Yeti crab is mobile, carrying its bacteria with it, while the tube worm remains anchored, hosting microbes within its body to feed. Some Pompeii worms live directly against the hottest vents, where temperatures exceed 80 degrees Celsius, conditions that would be lethal to almost any other organism. Beyond interspecies competition, conflict within the same species is common. Where food is present, individuals must fight for their share. The Humboldt squid is a classic example. At night, pods of dozens of individuals rise from the depths to hunt schools of small fish. They cooperate to corral their prey, but compete fiercely for the spoils. The strongest dominate, and they have even been known to prey upon smaller members of their own pod. This relentless competition has driven deep-sea evolution, the mastery of light, bodies that defy crushing pressures, and an energy-efficient hunting tactics. In the frigid gloom of the seafloor, competition is more than a fight for survival. It is the invisible hand that defines the entire marine world. From organisms that glow in the dark to the colonies thriving around volcanic vents, every life form bears the scars of this never-ending struggle for energy. In this dark and mysterious realm, competition has forged one of the most complex systems on Earth, where life persists against all odds. In tropical seas, where the sandy floor meets coral gardens and seagrass meadows, a strange being moves through the shadows. This is no ordinary fish. With massive eyes, a supple body, and skin that transforms in a heartbeat, the cuttlefish is one of the most sophisticated organisms in the sea. A member of the cephalopod class, there are currently about 120 known species, widely distributed across the globe's tropical and temperate waters. Interestingly, they are almost entirely absent from the waters of North and South America. They vary in size from a mere 10 centimeters to the giant cuttlefish, which exceeds 10 kilograms. The cuttlefish's hallmark is its near-perfect camouflage. Its skin contains millions of specialized cells that allow it to change its color and pattern instantly. The outermost layer consists of pigment-filled cells in shades of brown and red. Beneath them, iridophores reflect light to produce shimmering metallic hues. Even deeper lie leucophores, which reflect the ambient white light of the environment. This layered system allows the cuttlefish to vanish against sand or coral. They go beyond color. They can also alter the very texture of their skin. Small muscles create bumps or smooth surfaces to mimic rocks or kelp with startling accuracy. In seconds, a cuttlefish can simply cease to exist to the eyes of its enemies. But camouflage is only one tool in its survival kit. They are highly effective hunters. Their preferred prey includes shrimp and crabs, though they will tackle small fish or other cephalopods given the chance. Upon detecting a target, the cuttlefish stalks silently. At the critical moment, it strikes with two long tentacles at lightning speed, snaring the prey before it can react. It uses a powerful parrot-like beak to crush hard shells, delivering a bite strong enough to pierce armor while injecting a paralyzing neurotoxin. One of its most bizarre hunting tactics is the hypnotic display. They ripple dark bands of color across their bodies, leaving the prey confused and disoriented. While the victim is entranced, the cuttlefish moves in for the kill. These incredible abilities are powered by a highly developed brain. The cuttlefish possesses an extraordinarily complex nervous system. It has a sharp memory, the capacity to learn, and a remarkable ability to solve problems under stress. Experiments have shown they can remember spatial and temporal data, much like mammals. Their eyes are also a masterpiece of evolution. They can detect polarized light, a signal invisible to most animals. This allows them to spot camouflaged prey and communicate with their own kind. When cornered, they employ a classic defense, ejecting a cloud of thick black ink to baffle the attacker and facilitate a quick escape. This ink cloud doesn't just obscure vision. It creates a pseudomorph, a false shadow, that tricks the predator into attacking empty water while the cuttlefish flees to safety. Certain species, like the flamboyant cuttlefish of Southeast Asia, carry potent toxins in their flesh. Their vivid colors serve as a warning to any would-be predator. A cuttlefish's life is brief, typically lasting only 1 to 2 years, but its life cycle is filled with spectacular reproductive events. One of the most stunning occurrences involves the giant Australian cuttlefish. Hundreds of thousands gather at coastal spawning grounds, creating a massive congregation unique on our planet. Here, males engage in fierce competition for females, shifting colors constantly to intimidate rivals and display their physical prowess. Not all males win through brawn. Smaller, sneaker males use cunning. They mimic female coloration to bypass larger rivals and mate, while the dominant males are busy fighting. After mating, the female deposits hundreds of eggs in secure crevices. There is no parental care. After 4 months, the tiny cuttlefish hatch and must navigate the world alone. Another unique feature is the cuttlebone, a rigid internal structure of calcium carbonate. By adjusting the gas and liquid levels within it, the cuttlefish maintains perfect buoyancy. Despite their short lifespans, they are resilient and capable of rapid population recovery. Today, most cuttlefish species are considered stable in the wild. In the vastness of the deep, the cuttlefish stands as a supreme example of intelligence, a soft, fragile creature equipped with truly awe-inspiring evolutionary gifts. Beneath the shimmering surface of tropical seas lies a world both fragile and magnificent, where sunlight pierces the crystal water to form dancing pillars of light. Here, coral branches rise like petrified forests, and massive reef blocks form labyrinths that host a flurry of life within every crevice. This is the world of the coral reef. Though they resemble motionless stone, they are actually built by tiny animals known as coral polyps. Each polyp is a soft organism related to jellyfish, capable of secreting a calcium carbonate skeleton to shield itself from environmental hazards. Over millennia, these layers accumulate to create the titanic structures we see today. Nature has built underwater metropolises so vast they are visible from space. Coral reefs are found throughout the warm waters of the Atlantic, Indian, and Pacific Oceans. Fringing reefs hug the shorelines of islands like a vibrant living border. There are also barrier reefs situated far offshore and ring-shaped atolls that encircle internal lagoons, the biological remnants of sunken volcanic islands. A reef grows with agonizing slowness. Many species expand by only 1 to 3 centimeters per year. Yet, this construction has persisted for countless generations. Corals reproduce asexually through budding or sexually during rare synchronized events where millions of polyps release eggs and sperm into the water on a single night. At these moments, the sea appears to be filled with living snow. From tiny larvae drifting on the currents, an entirely new reef can begin to take shape. Although they occupy a tiny fraction of the seafloor, reefs host a quarter of all known marine species, earning them the title the rainforests of the sea. Among the branches, clownfish find sanctuary in anemones. Butterflyfish glide over painted surfaces, and angelfish shimmer under the tropical sun. Meanwhile, parrotfish use their powerful beaks to scrape away algae, indirectly creating the fine white sand that defines tropical beaches. In the cracks and shadows, shrimp and crabs scavenge for organic matter. Sea urchins graze on algae, and mollusks hide as the discreet citizens of this submerged city. When night falls, the reef's rhythm shifts. Diurnal residents retreat to rocky caves, making way for a nocturnal world that is only just waking up. Lobsters emerge to forage, and moray eels peer from crevices, while polyps extend their stinging tentacles to snare drifting particles. In some areas, bioluminescent organisms cast a faint blue glow, making the reef look like a fairy tale kingdom submerged in the darkness. At the heart of this system is a biological pact, the symbiotic bond between coral and microscopic algae called zooxanthellae that live within their tissues. These algae perform photosynthesis, providing the coral with organic matter and oxygen. In return, the coral offers them sanctuary and the chemical compounds they need to thrive. This relationship produces the reef's vibrant colors and allows them to grow in nutrient-poor waters. Beyond their biological beauty, they play a vital economic and ecological role. They act as natural breakwaters, absorbing the energy of storms before they strike the coast, thereby protecting human settlements from erosion. Furthermore, reefs serve as nurseries for countless valuable fish species, providing food security and livelihoods for millions of people. However, these structures are incredibly sensitive. Rising sea temperatures can sever the symbiotic bond, causing the coral to bleach and die. Ocean acidification, land-based pollution, and destructive fishing practices threaten to collapse this fragile ecosystem if urgent action is not taken. Yet, the reef is not yet silent. In many regions, scientists and local communities are actively restoring healthy corals through nursery and gardening techniques. The coral reef is more than just a beautiful landscape. It is a monument to time and a sanctuary for thousands of species that depend on nature's perfect balance. Looking at this secret world, we realize a fundamental truth. Often, the smallest organisms are the ones that construct the greatest wonders of our planet. By moving just a few hundred meters from the surface, the sea transforms into an entirely different realm. Sunlight fades until it is extinguished. Temperatures plummet toward 4 degrees Celsius. Pressure mounts to levels that would crush almost any form of life familiar to us on the surface. Beyond 1,000 meters, we enter the midnight zone, a kingdom of perpetual darkness. Yet, in this frigid void, life persists in strange and incredible forms. Deep-sea organisms have evolved in extreme ways to withstand the cold and the weight of the water. They don't just exist in this hostile world, they master it. The first adaptation is found in body shape and color. In the shallows, color attracts mates or warns enemies of danger. But in the deep, color is used for concealment. Many species are jet black or deep red, rendering them invisible to predators. Red light is the first to be filtered out by water, so in the deep, it effectively becomes black. Thus, beings like the vampire squid are perfectly cloaked in their environment. Other species choose near transparency, allowing the meager remaining light to pass through their bodies. But as prey becomes harder to see, predators must also evolve. In the abyss, eyes are tuned to detect the faintest signals of life. Some species have developed unnaturally large and sensitive eyes. The barrelly fish is a prime example. Its tubular eyes can rotate upward within a transparent head. They scan for the tiny glimmers emitted by other organisms in the void. A small flash can signify a meal or a warning. Many deep-sea residents have long, soft, slender bodies to conserve energy. Minimal muscle mass and light skeletons reduce metabolic costs in a world where every unit of energy is a precious commodity. Many do not hunt actively, instead surviving on marine snow, the constant drift of organic detritus from above. This energy efficiency is their primary survival tool. Meanwhile, some species have evolved abyssal gigantism. Crustaceans that are microscopic at the surface can grow to tens of centimeters here. The giant amphipod can exceed 30 centimeters, while the giant isopod reaches the size of a domestic cat. This is an adaptive response to the extreme environment. A massive body helps minimize heat loss and slows the metabolic rate. In the deep, living slowly is often the ultimate evolutionary advantage. Within these organisms, extraordinary physiological shifts occur. The most iconic adaptation is undoubtedly bioluminescence. The deep sea sparkles with light signals generated by the organisms themselves. Fish, squid, and jellyfish glow through controlled chemical reactions in their tissues. This light is used for communication, mating, or distracting predators. Some species even use ventral lights to erase their own shadows, hiding from attackers below. In sub-freezing waters, certain fish species have evolved antifreeze proteins in their blood to prevent their tissues from crystallizing. These molecules inhibit ice formation, allowing life to persist in liquid ice. It is a physiological breakthrough that opens a habitat inaccessible to most. However, biology is only part of the story. In the deep, behavior is a cornerstone of survival in conditions of extreme scarcity. Many organisms exploit every organic source falling from above. Polychaete worms secrete mucus nets to snare descending marine snow. The vampire squid deploys long sensory filaments to collect drifting debris. On the floor, sea cucumbers swallow sediment to filter out remaining nutrients. Scavengers wait patiently for a whale fall, a rare feast in the middle of a biological desert. Another stunning behavior is the deal vertical migration. Every night, billions of organisms swim toward the surface to feed. Retreating at dawn, it is considered the largest migration on Earth by total biomass. This mass movement drags predators in its wake, creating a ceaseless biological rhythm. The deep sea is not a dead void, but a dynamic evolutionary laboratory. Pressure and darkness have forged alien bodies and sophisticated strategies. In the abyss, evolution favors pure efficiency over conventional beauty. It creates life forms that may seem terrifying, but in that strangeness, the deep sea reveals that when pushed to the limit, life always finds a way. life will change, adapt, and, in the most incredible ways, continue to persist despite the crushing challenges of the abyssal environment. Not all alien worlds are found in distant galaxies. On this very planet exists a world nearly as foreign to humans, the deep ocean. Where light cannot reach, where pressure crushes metal, and where temperatures are glacial, life thrives. Contrary to old beliefs, it is not a barren wasteland. In the dense darkness exist life forms humans would scarcely believe if they did not see them with their own eyes. These are beings that defy our logic. The life here bypasses our intuition. Some have giant, translucent eyes, while others have abandoned sight entirely as a useless luxury. There are species with eyes housed inside transparent heads. Many organisms emit their own biological light to lure prey or camouflage themselves in the infinite abyss. Without photosynthesis, the food web is precarious. Some organisms that were originally zooplankton have evolved into highly specialized predators. They feature cavernous mouths or rows of needle-sharp teeth growing in every direction, perfectly adapted to snare anything that crosses their path. The upper layer is known as the twilight zone, extending down to 1,000 meters. A fraction of light still reaches here, but colors bleed away as we descend. Many organisms wear a dark red skin, making them virtually invisible in this light. It is a master survival strategy refined over eons. A classic resident is the vampire squid. With large eyes and a crimson body, it looks like a nightmare creature, though its nature is far gentler than its name suggests. Its diet consists of marine snow, organic fragments falling from the upper tiers. Drifting in the depths, it harvests these particles with its tentacles. Thanks to an extremely low metabolic rate, it can survive on very little energy. Descending further, the organisms become even more bizarre and mesmerizing. The bigfin squid possesses arms up to 8 meters long that dangle like delicate threads. Scientists still do not fully understand how this species hunts. It is thought to use its long tentacles to snag small organisms floating in the water. Meanwhile, others adopt passive feeding strategies. Carnivorous sponges, relatives of the harmless surface species, have evolved small hooks to snare organisms swept by the current. They do not move or chase, they simply wait in the absolute dark. In the deepest zones, food scarcity has created extreme efficient killers. The anglerfish lures prey with a glowing beacon produced by bacteria. When the victim approaches, its massive mouth snaps shut, leaving no hope of escape. Some individuals can swallow prey larger than their own bodies. In the twilight zone, the barrelly fish watches for glowing prey from below with its tubular eyes. Thanks to its transparent head, it can spot camouflaged organisms. However, as we go deeper, the sense of sight becomes increasingly futile. Some organisms have abandoned eyes altogether. The tripod fish stands on the seafloor on 3 long fins, sensing vibrations in the water. Instead of looking, it detects prey through touch and motion. This strategy saves vital energy in a world where food is a rare luxury. Scientists have even documented snailfish living at depths of 8,300 meters. Their soft, translucent bodies allow them to withstand the crushing weight of the abyss. Though it appears fragile, this fish persists in an environment that would destroy most vertebrates. The denizens of the deep both amaze and unsettle us. Their strange forms are not random deformities, but the result of millions of years of evolution under relentless pressure and shadow. Thanks to modern technology, we have only just begun to see a tiny fragment of that world. It is the final frontier, still holding countless secrets yet to be unveiled. By exploring these depths, we realize that life is far more resilient and creative than our limited terrestrial perspective ever imagined. The evolution of marine organisms is a saga of hundreds of millions of years, written in the dark under colossal pressure and in extreme environments. The bizarre life forms we have explored are testaments to the power of adaptation. But evolution does not only occur on the seafloor, it happens across our entire planet. On dry land and within the human body itself, the process continues silently. Human vision is complex, but the brain can adapt even in its absence. Remarkably, even when sight is lost, the human brain learns to perceive the world in alternative, startling ways. Some who are blind use sound to map their surroundings, creating an acoustic blueprint that helps them recognize distances, shapes, and obstacles with pinpoint accuracy. This is the essence of evolution. The Earth as a planet of ceaseless experimentation, where every ecosystem is a natural laboratory where life constantly reinvents itself. But the future of these ecosystems is inextricably linked to humanity. Today, even the deepest trenches suffer the influence and impact of our activities on the surface. Plastic waste and industrial chemicals have been detected where light never reaches. Organisms thousands of meters away are impacted by our choices. This means that every one of our small actions can turn the tide. Reducing plastic waste and limiting pollution is a collective duty. We must respect the nature and the ecosystems that took millions of years to forge. For the deep ocean is an integral part of our planet's life support system. If you enjoyed these exploration journeys, please like the video and subscribe to the channel to continue discovering the most mysterious regions of the Earth together. Each video is a new expedition to admire nature's beauty and better understand how this world functions, so that we may protect it more effectively. Because the story of life on Earth is far from over, and we are only just opening the first door toward the true knowledge of our planetary home.